All right, number one, sketch a graph of the function. I am going to begin that by doing a little bit of factoring. So actually I'll do it below it. The top part is I can factor out a 2. And the denominator I can factor into two binomials. I need two numbers that multiply to make negative 24 that add up to 10. I believe they are 12 and negative 2. Okay. So with that idea, I can cross off the common factor on top and bottom, x minus 2 and x minus 2. While I'm at it, that means that I have a hole in the graph at x equals positive 2, because it's the opposite of those numbers. So again, that comes from right there. Finishing up the simplifying, so 2 over x plus 12 is now what I'm looking at. Because of the denominator there, that means I have a vertical asymptote at the opposite of 12, which would be negative 12. So x equals negative 12. So as far as the graph goes, I can go over to my graph now and I can be certain that I have, if I count over 12 spots, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I have a vertical asymptote there. Turns out this graph is just kind of shifted pretty far over there to the left, so it might be helpful to grab a calculator at this point, but I'm fairly certain that the graph of this thing is going to look like this. You can pull out a graphing calculator or a graphing app to check that, but I think that's what it looks like. The horizontal asymptote is going to appear to be y equals 0, and again, that's just sort of this concept that the graph sort of flattens out right on the x-axis there, and that's the line y equals 0. I was about to move on, but I just realized I didn't graph the hole in the graph. The hole happens at x equals 2, and in this graph, since it goes to the right forever, I need to add in that it has a hole over there at positive 2. Let's move on. Oh, by the way, I did check that problem on the calculator. That is what it looks like. You kind of have to change your graph window to see it, though. Number 2, simplify and determine the restricted values. Okay. Well, I can factor the top of that to be two numbers that multiply to be 6 that add up to 5. That's 3 and 2. The denominator can factor to be two numbers that multiply to make negative 15, add up to 2. That's going to be negative 5 and positive 3. And now I can see that I have common factors, these guys right there, those cancel out, and that leaves me with a new equation, x plus 2 and x minus 5. Now we've talked about how as soon as you find yourself doing this business right there of crossing those off, that actually leaves you with what we call a hole or a restricted value. So I can basically add on to there that while the simplifying thing is true, there is an issue with the number negative 3. Now, it may not have been clear in class, but just in case you're wondering what's going on, if you grab a graphing calculator and graph that, and you graph this, the graph will look identical. However, in reality, this graph does not have a hole at negative 3, while this one does. But visually, they look the same everywhere except for at the number negative 3, and that's basically what we're trying to identify. Moving on. Letter B, we can factor the top of that by dividing by a 3 or factoring out a 3. On the denominator, I can factor a 3 out of there too. So 3 times 2 would be 6. 15, 3 is 3 times 5. And there's that. And we can cancel those common factors off. And I end up with this equation here. That one does not have any restricted values because I did not cross off an x. I just crossed off the 3 and the 3. Whereas over here I crossed off an x plus 3. It's different. Moving on, little ACT practice here. What is the x-intercept of that graph? I feel like we've seen that problem recently. That's going to factor like this. And there we go. The thing about those is that they're exactly the same, which means technically I could rewrite this as a single binomial and just put a little squared on it. And basically that means that that graph is has a x-intercept, which is where you set it equal to 0, and we just go what number minus 2 would give you 0. In that case, that's 2. You can go check a graph, you'd see it there too. Moving on. Which of the following is a factor of that polynomial? Alright, this one's a little bit more complicated because of that number in front. That's going to require me to do a different method where I take this, what we call the A number, and I'm going to multiply that times this back number, -5. That's going to give me the number -10. I'm just going to sort of think about that for a second. I need two numbers that are going to make that -10, but are going to add up to be the middle number -3, in which case that's actually this pair right here. However, I can't just go straight to an answer here. I actually need to use some sort of technique. In this case, I'm going to use what we taught. It's called the box. And what I can do is I can take the first part, 2x squared, right into there. The c number is -5, and these two numbers go into there as well. It's just a coincidence they're all sort of matching up there. That's a little confusing, sorry. Alright, and so hopefully you've seen this technique before. So here we go. We have the greatest common factor of 2 and 5. 2x squared and 5x is actually just an x. Furthermore, down here, greatest common factor of 2 and 5 would be 1. Up here, greatest common factor would be 2x, and back here would be -5. And so this problem factors to be x plus 1 times 2x minus 5. And if you check out our answers over there, that would be f. No, it wouldn't. I'm wrong. That is not good. That said -1, and this says +1 down there. +1, -1, that's not the same thing. It's this one. So sorry, but there you go. Done.